Let's start with octahedral complex. This is one of octahedral complex. Firstly, we will find the valence shell electronic configuration of cobalt atom, which is 3d7 4s2. 7 electrons in 3d orbital and 2 electrons is 4s orbital. Then the next step is we will find the oxidation state of cobalt atom. And the method to find it is that let's consider the oxidation state of cobalt is X. There is 6 number of ligands, so 6. Charge on one CN atom ligand is -1, and the total charge on this coordination sphere is -3. So it will comes out to be +3. So cobalt atom will give up 3 electrons to form CO3 positive. 2 electrons from 4s orbital 1 and 2 and 1 electron from here, this paired electron. So now the electronic configuration will become 3d6. Okay. Now we will see that which type of ligands is given. The ligand given is Cn, which is a strong ligand, and we know that the strong ligand have the tendency to pair up the electron. So it will pair up the electron. This electron will come here, pair in this, and this electron will pair up with this electron. So it will become like this. Now these two orbitals will be vacant, and 4s orbital is vacant and 4p orbital is vacant. The number of ligands will be 6. So lone pair of electron of one ligand is this, second is this is third, fourth and fifth and sixth. So hybridization will become D2sp3. So hybridization is D2sp3. As the d orbital involved belongs to inner n-1d orbital in the 3d orbital, so this is the example of inner orbital complex. Also, from this ligand, we can find this coordination compound. We can find magnetic moment. As we can see that there is no unpaired electron. All the electrons is paired. So unpaired electron is 0, and this coordination compound is diamagnetic in nature. Okay? Magnetic moment will be 0. And if we see the another example of coordination compound in which same central metal atom is used but the ligand is different. Here it is Cn and here it is fluorine. So we will see that what happened in this coordination compound. Firstly, first step is to write the valence shell electronic configuration of cobalt atom. That is why 3d7 4s2. Next step we will find the oxidation state of cobalt atom. Let it be X. There is 6 number of fluorine atom. Charge on one fluorine atom is -1. The total charge on this coordination sphere is -3. So X also comes out to be +3 in this coordination compound. So cobalt atom will give up 3 electrons to form CO3 positive, and the electronic configuration will become 3d6. 2 electron from 4s orbital and 1 from this paired electron, and so it will become 3d6. Now fluorine is a type of weak field ligand. Weak field ligand. And weak field ligand do not have the tendency to pair up the electron. So in this coordination compound there will be no pairing. It will remain same, and the lone pair of electron of fluorine ligand will enter into first this s orbital, then these 3p orbital, and the next 2 lone pair of electron will enter into outer 4d orbital. So here the hybridization will become sp3d2. sp3d2 hybridization. Since the electrons enter into nd orbital, outer orbitals, So these are the example of outer orbital complexes. We can also find the magnetic moment as the number here number of unpaired electron is 4. So when we have unpaired electron, the coordination compound is paramagnetic in nature, and we can also find the magnetic moment also. By the rule n plus 2 under the root. Here the value of n will be 4. So the magnetic moment we can calculate here by this formula. Okay, this is the magnetic moment comes out to be some have value in this coordination compound cobalt F6 3 negative, and in this complex magnetic moment is 0 because the value of n is 0. So this is two very different examples of octahedral complex in which the nature of ligand is also different, and the magnetic moments which comes out is also different. They are also the example of inner and outer orbital complexes. I hope you like the video.